बचत केलेले पैसे चोरण्याचा सायबर क्रिमिनल्सला हा डाव असू शकतो, अशी कोणतीही घटना घडल्यास नॅशनल सायबर हेल्पलाईन 193 वर गृहमंत्रालयाद्वारे त्याचा करता येईल.
they are having the surplus electricity. Okay, they have their separate those countries, Scandinavian country and other European country. They have their separate grid. Okay, so if suppose so that surplus energy electricity we can use in converting the hydrogen, and the hydrogen we can use whenever it is needed. So it is the excellent energy carrier, or say excellent energy storage media, wherever we have the surplus energy resource in surplus electricity. So at the same time, it enables the decarbonization to hard to electrify the sectors such as the heavy transport, shipping, and industry. So now, and Norway and some Scandinavian country, they are they are focusing on green hydrogen based shipping, shipping industry, shipping and other industrial applications. And of course, it provides a clean fuel alternative to the industrial application like the steel making. And now these days, government has also and DST has also announced one scheme for the steel industry, and there is the carbon decarbonization in the steel industry recently. And the last date is, I think, in the first somewhere in the first week of June. So you people may apply for this for that call, right? And contribute the global climate target to lowering the dependence on the fossil fuel, and backed by increasing trend, because it is lighter than air. That means it dissipates very fast. Okay, if suppose some leakage is there, and it dissipate very fast, so there is very less chance for some accident. And if suppose the space is not confined, right? If there is open space, and it will dissipate very fast. Definitely, if some confined space is there, so then it can be dangerous. So, and primary health safety concern is that the leakage go undetected, because odorless is this is odorless, and gas collected in the confined, this and eventually ignite and cause the explosion. If suppose the confined space is there and some ignition is taking place, it can be by with the electricity plug itself. Okay, switch on, switch. So it could be caused for the ignite and cause of an explosion. And of course, the thorough understanding of the hydrogen property and designing safety feature into hydrogen system, training in the safe hydrogen storing and handling practice are the key element for the ensuring the safe hydrogen. And the USA Department has stated that as more and more hydrogen demonstration get underway, the hydrogen safety can grow and build confidence that the hydrogen can be safe and fuel in widespread use today. So that confidence will come when we apply as more and more. Definitely, right? Of course, the risk is there. And this is, look at over here, that this is the global hydrogen demand and its share on the various applications. So various application means ammonia production, oil refinery, methanol production, right? So maximum share is 50%, 51% is from ammonia, and the oil refinery is 31% only, the methanol is this. And how, just see the growth rate. In others, definitely is not that the slope of this line is not that much, but in case of the methanol, and you just see the oil refining industry, how demand is increasing, right? The share in the oil refining is keeps on increasing, and in fact, it is much faster than the ammonia. Okay, in the ammonia means some ammonia is being used in many industry, and the fertilizer industry is one of the best example for that. Okay, and of course, recently the most of the developed country have been using this hydrogen as a transportation fuel. Hydrogen fuel cell based vehicle itself, and also the fuel cell used for the generation for the electricity, and right. And now our main focus is basically as we consider the future demand. Okay, it is important to find the route to reduce its production cost, right? And now the this is just forecast. This is the basically forecast by the Maka EU Atal. So the hydrogen demand worldwide, how it keeps on increasing. Okay, this in the transport sector, definitely hydrogen demand is keeps on will be very high. This is our projection, and 19. This is the actual data 19, and these are all the projection basically. Okay, forecasting. So it is means predicted that this in 2070, definitely by 2070, as we have also fixed our target to for the decarbonized based electricity will be there by 2070. We will not use any fossil fuel based, right? So this is basically the global hydrogen demand by sector, and the different sectors are there. They are indicated with the refining, building, ammonia production, industry, power, syn fuel production, and transportation. So huge demand will be either on this transportation sector or the syn fuel production, synthetic fuel production, and of course the power also, right? Power, industry. So means many developed country or the underdeveloped developing country like India, we are means India government is focusing very much on the product and the production of the means production cost to reduce the production cost of the hydrogen, and for the application in the different energy demanding sectors. Okay, okay, now yeah, you see the supply. This is supply and demand side. So these are the different energy sources, right? So whether this is nuclear heat or electricity, okay. Nuclear heat directly we can use for the hydrogen production, okay. And this nuclear electricity, solar, and if renewables are there, solar, hydrogen, wind, okay, solar thermal, biomass, okay. So that and in fact, if electricity from these renewable sources we can use, we can produce hydrogen with the help of the electrolysis process, okay. And other the natural gas and coal also we can use. There are different techniques are also that also in the for the converting the coal into the this hydrogen, but these are very expensive. Those technology are still not cost effective, and we can use for the different industry like turbine, IC engines, process synthesis, poly generations. The different industries are there, and of course in the built environment, in the building sector, the tertiary, residential, commercial, we can use the fuel cell, okay, and fuel cell based engines for the transportation, and IC engine based on the hydrogen. Now a lot of research is going on in to develop this develop or this internal combustion engine based on the hydrogen fuel, right? And now the cost, in fact, very have documented that the hydrogen energy has been grown drastically in the by 2020. It has potential to unlock the 8% of the global energy demand with the production cost of 2.5 USD per kg. And it is also being predicted that by 2030, the hydrogen production cost is expected to be lower than the 1.8 USD and unlock up to 15% of global energy system. No, sorry, a global energy demand. Okay. So and the H2 the cost of the H2 varies wide between the 0.8 or in some places it is more than the 4 USD per kg. That all depends on the resources and the labor cost. Okay, and resources, labor cost, and technology. So these are the three factors. Because of that, because of this, you can see, in the next figure itself, how the cost is vary in the different region in the globe. Okay, and this is the Indian status basically. The green hydrogen cost in India could reduce by 2030 to INR 230 to 40 rupees per kg, with the measures announced in the national hydrogen policy, or in fact the national green hydrogen policies there. Okay, and this Institute of Energy Economics and financial analysis, and they have also done some work over there. And Bloom's new energy uh, new energy finance. This BNEF means this uh, means this figure I have taken from this Institute of Energy Economics and Financial Analysis. Okay, so now this is the estimated greenhouse production pre and post hydrogen production policy. Okay, so this is because this that is the basic 20 to 30% reduction in the cost is there. Okay, and this and of course the gray hydrogen cost is also decreased the 25 to 30%. Okay, and this boosting domestic solar PV manufacture will fuel green hydrogen takeoff in India. Definitely, the government is doing a very considerable efforts for reducing the cost of PV manufacturing. And right now we are heavily dependent on other country for the PV manufacturing. But very soon we will, I hope, we will also produce very cost-effective solar photovoltaic module. Okay, so this the major renewable sector player plan to beat the fossils hydrogen, and you can see over there this BNEF stands for the Bloom's New Energy Finance. This is cost production by this analysis is done by this. So Reliance Industry and target the around the $1, $1 and NTPC target is $2. Okay, green hydrogen is still very expensive, the $5.5 per kg, and this hydrogen from the natural gas is the cheaper because we are using the fossil fuel or the natural gas only. Right, so this cost is $2 per kg hydrogen production. Now, you please have a look on this, the cost of the hydrogen. See the variability. Lot of variations are there. Okay, so major hydrogen consumption is in Asian country, in Asia. Okay, no, the major is in Europe. Sorry, I'm very sorry. Okay, so major hydrogen consumption is in European country, right? And then the Asian, then the America, whether this is North, South, and Central America, and then this African country, and then Australia. So with the help of this figure, you can see, and further these countries are there, and this over there among them the America, the North America is a major consumer for that green hydrogen. So not green hydrogen, the hydrogen consumption. And you can see the H2 production cost varies in North America. If we consider this, the 2.6 to 3.4 USD per kg. Okay, and at the same time, in the South Asia, if you see in the South Asia, especially in India, this hydrogen production cost is only the 1.1 US dollar to the 2.6 US dollar per kg. Okay, so that all depends on the technology, labor, and natural resources. What kind of resources are there for hydrogen production, right? So, and there are the different cost parameter of the cost parameters where the cost is involved. So operational cost is there. Okay, total capital investment is there, and hurdle metrics. So means ultimately our aim is to H2 production cost. We have right estimate the H2 production cost and plant profitability and comparative economics. So these are our ultimate aim. Aim means to estimate this or ultimate aim of for the cost analysis, to get it the complete picture in terms of the S2 production cost, plant profitability should be there. Definitely, any industry is there. Uh, the industry is set up for the some profit only. No? So comparative economics is very important. So variable cost, fixed cost is there under the total capital investment, the direct and indirect. In indirect, the installation factor, engineering supervision, construction expenses, legal expenses. Sorry, contractor expenses, contingency, some other expenses are also there. Instrumentation, direct cost, control system, pipeline, electrical system, building, in operational cost, raw material, utility, labor, overhead, maintenance, repair, right? So these are the many this costs are involved. So and you can see over there in how the various energy sectors are involved for the hydrogen production. Okay, so now the renewable energy, various renewable solar, wind, biomass, geothermal, ODAC, many. Okay, so the renewable resources. Uh, and nuclear energy, of course, the nuclear energy, the electricity produced from the nuclear energy, fossil fuel based electricity, right? If we have the
लगभग
access,
खत्म होने में है मैम
if we have the excess amount, then definitely the energy
ये ड्यूटी
storage.
खत्म ही नहीं होती
And the electricity the electricity generated from various energy sources, whether renewable energy,
आ रहा हूँ
nuclear,
मैम आज यस मैम
that can we can use with the help of the grid for the hydrogen production, right? And and of course, this hydrogen have the many applications in the fertilizer industry for direct heating, transportation, petrochemical, synthetic oil production, and further again we can use for the power generation. If we have, I think there some disturbance is there. Could you please? Yeah, thank you. So hydrogen basically classified based on the production method, sources, and carbon emission, right? So you can also see over there green, blue, gray, brown, turquoise, purple, pink, red, and over there the electrolysis by the renewable energy sources and fossil fuel where the CO2 is captured. Over there, then the blue carbon capture technology through the CO2 is captured carbon, right? And this is a natural gas utilizing for the SMR method for producing this such kind of hydrogen is known as gray, brown, black, coal, turquoise, methane pyrolysis, purple, electrolysis by the heat and nuclear power, pink, electrolysis by the electricity from the nuclear nuclear power plant, red, and natural hydrogen white, right? So these are the other type see which this the other type of include the blue hydrogen. Okay, fine. So now these are the different stages involved in the hydrogen industry, hydrogen production industry. So in the production could be from the steam, methane reformation method, electrolysis, biomass gasification, photochemical and water splitting method, thermochemical process are there, and definitely storage is another challenge for the 3-way, 4-way, and 5-way cylinders, and which can sustain the 700 bar pressure, right? So this is a very challenging area for the research. This for producing the cost-effective hydrogen storage cylinders, right? Then transportation, wherever is demand for the hydrogen, then definitely an application, various applications are there. And this production, see the current source, the different natural gas, oil, coal, and electrolysis. These are the different, and of course the 48% from the natural gas only, right? Green hydrogen is producing from the natural gas. And the hydrogen and consumption over there in the ammonia for various industrial application and the fertilizer, then methanol, oil refining, and others. So these are the sustainable application for the green hydrogen over there. So application for the green hydrogen. Okay, different applications: agriculture, synthetic food, aviation, transportation, energy storage. That have environment impact on the sustainable application, of course. Okay, so these are the different H2 storage method. We can classify into the this physical storage and chemical storage. And physical storage: compressed hydrogen tank, liquid hydrogen tank, and cryo compressed hydrogen tank. And in case of the chemical storage, the metal hydride, chemical hydride, and sorbent method. And you just see over there S2 storage cost. This is another very important factor. And so this in fact this storage is the main issue with this. Another main issue for the hydrogen transport, storage and transportation. Okay, and highly, this is because it is highly combustible and very low volumetric density is there. So therefore it is very difficult to store even a small quantity. And if suppose high pressure is not there, where large space is needed. So liquid and the compressed is widely used for this hydrogen large scale, and liquefaction of the hydrogen require the significant energy input. And because the boiling point is very low, that is minus 253, and but liquid hydrogen provides a comparatively very high storage density, and liquefaction consumes around the 30% of the hydrogen energy. Cost hydrogen 30% hydrogen. So this is right now. It is you can say this could be the problematic, but later on, as the advancement in the technology will takes place, so definitely we could overcome all these issues.
खुशी आपका सारा सेट है
Okay, so now this is compressed storage, liquid hydrogen storage, and metal hydride storage. You can see the cost of the hydrogen storage with the various technologies, and the least is with the compressed gas storage over there, and then the 48 and the 110 rupees per kg of this. The cost of the transportation again this, because after storage definitely we have to transport. So, but the liquid in this case, the liquid hydrogen storage having the least transportation cost among all these. So over there means storage. In case of the storage, this compressed gas storage is cost is less, but in case of the transportation, the liquid hydrogen storage is less, and the cost of the fueling station, the fueling station is lesser in case of the compressed gas storage. So means we have to decide based on all these factors, right? And of course the risk is there as we have coefficient of diffusion and the lower density much faster than this fuel, the high specific heat, and gaseous hydrogen having the very light density, means 6.9% of the air density is more dispersive compared to this. But the gas leakage diffuse and is developed in the source, lowers the risk of the blast. The leakage of the H2 is not as for damage the climate due to the non-toxic factor. Okay, this is so additional security benefit for the H2 is connected accompanied with a clear flame. And of course, the opportunity in India for green hydrogen, for promoting green hydrogen. The green hydrogen will help definitely sustain. It is a sustainable solution in India for the Indian transport sector. As per TRADE, the demand for the hydrogen in India will increase from the 6 metric ton to 28 metric ton by 2050, and the cost of the hydrogen from the renewables will fall from 50% by 2030. So a lot of research and advancement in the research is taking place right now. Many institutes like the IIT, IISc, and many NITs are involved over there. And TERI also claimed so definitely it will be there, and it will be 100% by the 2070 itself. Under the government of India. Very ambitious scheme, this Make in India program. India has opportunity to start the production electrolyzer and the fuel cell, which allow the capturing the large share in the market. So this is another target of government of India. Okay, for producing cost-effective electrolyzer. So lots of the grant is available from the MNRE, and DST is also for research. So many Indian institutes like Indian Space, ISRO, IUCL, Bharat Petroleum, Tata Motors, they are very actively working with the hydrogen and fuel cell technology. And okay, so there are a lot of opportunity other than because of this. And now, of course, there are a lot of benefits in the reducing the petroleum import and energy security. This is a major thing. We are heavily dependent on the this crude oil. The decarbonization of the transport sector, the transportation, of course, means one of the major sector for the carbon emission, integration of the renewable and the hydrogen production, right, and address the climate change. So these are the benefit basically, and you can see the India's total installed renewable energy capacity has reached to 1,75,700 megawatt till 30th April 2025. So we are very means we are our electricity production from the renewable sources, the growth rate, you can say the growth rate is very high. Okay, so you can see over there the highest share is from the solar power. Almost this is 1,08,000 megawatt, and wind is now the almost around the 50%. Sometimes the wind, the electricity production from the wind was higher as compared to solar power in renewable energy among renewable energy sources. Now, just to see, we have very less hydrogen fuel station. One is in this Gurugram, and another one is this in Faridabad, the Indian Oil R&D Center. Okay, but you can see that in Japan, very high, more than 100. Germany around 80. United States around 60. In China around more than 50. Right, and India is having only the two. Just a moment. एक मिनट. Yes, so means this we have to do a lot of work in this sector, the hydrogen fuel station, and there are many government of India initiatives. This National Greenhouse Mission to become the major exporter of the hydrogen and incentive plan of the 2.11 billion. And this strategic intervention for the green hydrogen transition program site. Okay, site has there are the two mechanisms in the site. One is to manufacture the electrolyzer with 60 to 100 gigawatt capacity in India. This is the major target, and to produce the green hydrogen. And there are different regions capable for the producing, utilizing large scale hydrogen will develop green hydrogen hubs. And site there are the three phases for this. Okay, first phase to establish the policy and guideline initiate for pilot project. This phase was 22 to 24, and between the 25 to 26, and another phase is the we are a bit slow and whatever as per our planning. So to bring down the manufacturing cost and promote the incentive for the large scale production to scale up the production of the green hydrogen. And third one is a focus on the other distinctive hydrogen applications. Right. So these are the three phases up to the 2030, and there are many sustainable approach for the hydrogen production, water electrolysis, and in water electrolysis, the solid oxide electrolysis, anion exchange, high temperature photochemicals, and of course this biological hydrogen production is a dark fermentation, photo fermentation, hybrid system, biophotolysis, microwave fuel cell, the thermochemical hydrogen production, the biomass gasification, steam methane reformation, pyrolysis. These are different well-known techniques. Okay, but how to implement in the hydrogen production, it is in the detail in my, but I'm not sure I could able to complete. There is a photochemical water splitting, the single junction, dual junction for integrating uh, uh, photochemical, photoelectrochemical cells and the photoelectrochemical solar cells. Are also a lot of research is going on the photochemical solar cells. Plasma assisted. One of our scholar is working on the plasma assisted water splitting. So this very plasma is created with the help of the electrodes. The corona discharge plasma, dielectric barrier discharge, plasma microwave, and he recently filed one patent also. Okay, so these are the some fundamentals of water electrolysis and solid oxide working principle and all, dark fermentation among that technology, direct biophotosynthesis, thermochemical production. This microbial fuel cell is very another promising technology for the for this also produce the completely green hydrogen generation. Right, and this is the thermochemical. If suppose some biomass we have, so for the biomass, especially for the pyrolysis, gasification, steam reformation, for the methane, actually this one of my scholar have worked on the steam reformation, successfully completed his PhD. He has done some modeling, and I want to show his result also, but because of the time constraint, and we can discuss some other time. Okay, so that is for the pyrolysis biomass, plastic, coal, and waste, the coal biomass, miscible solid waste, heavy oil residue for the gasification, syngas, natural gas, light hydrocarbons. So this is this photochemical water splitting method is there, plasma assisted water splitting, very important, and some definitely that hydrogen challenging the hydrogen production, the technological, economical, regulatory policy, infrastructure. So a lot of things are there, means a lot of challenges are there in case of the hydrogen production. Definitely convert the excess renewable energy electricity into the hydrogen, the generate clean electricity using the hydrogen fuel cell, industrial integration, mobile integration, residential commercial integration. There are different means application, grid and sector coupling. Okay, so in integration, energy store, clean transportation, power generation, residential grid. These are all. So a lot of things are there. Technological advancement. I would like to discuss, but definitely time is very short. So hybrid green hydrogen system. This is the schematic for the hybrid green hydrogen system. Okay, so this is a alkaline and PM proton action membrane based, the multi-physics. Okay, electrothermal mass parameter. So right, this is the experimental setup. Okay, not from our lab. Some I have taken. Student have not mentioned actually. This is for. I would like to discuss many things. Some results from the other resources. Some others work, others research. We can have discussion. Bifacial. This is another the green hydrogen production for solar to the hydrogen ratio using innovative and the bifacial solar photovoltaics and the cool roof technology. So we can produce with that itself. You see this figure is from one of the this country, what is called this Middle East country. So Middle East people, those having huge amount of crude oil, they are also exploring the green hydrogen or the renewable energy sources. Okay, so hydrogen generation from the storage and all this. This is spectral solar, bifacial solar output for the. Okay, so I will share this all slide with you. Maybe it is this is just a compilation from the my lab research work from my lab and others work. This is a mathematical modeling for so might be helpful. Okay, you may go through, and I will send you some research paper also based on that. This preparation and this PPT were prepared. Right. So I would like to stop here itself because I have to join one another one important meeting. So very sorry for today. There are many things to discuss, but because of the time constraint, it is not possible for me to stay more. Dr. Chauhan or Dr. Tushar, are you there?
Yes, yes, sir.
Yeah, very sorry for today. Actually,
No, no, sir. It's very fortunate to have you, and with your techno-economics on the hydrogen technologies, we got insights into how hydrogen energy is proceeding in India as well as in the global world. So thank you so much for joining this session. In our simple request, you have agreed that you are in the hydrogen technology. So we are honored to have you in this session. Dr. Dr. Anil Kumar is recognized as world's top 2% most cited researchers and scientists. It is published by Stanford University, USA. So we are very delighted to have you, sir. Thank you so much. And Dr. Tushar, want to add something?
Dr. Chauhan, may I leave?
Yeah, very good morning to all of you. Good morning, sir. And I'm first of all to thank you for giving us opportunity to make this FDP very successful. And in a very short period, you have accepted our invitation to be a part of this FDP. I really thankful to you. And in future also, sir, we are also going to put some such type of workshop or even in some international conferences also. So we are looking for you and your presence there.
Thank you, Dr. Tushar. I'm really very grateful to you for giving me this opportunity. And of course, we will collaborate more than this. Right?
Yes.
And for today, I am very sorry because of I have to leave to my one important meeting is there.
No, sir.
And it's
No
right?
issue.
So
Yeah.
shall I leave now?
Yeah, sir. We
Yeah.
can leave.
Once again, thank you all for listening me.
Thank you.
All the participants, thank you very much. Yeah, thank you. Namaste. ठीक है राजपूत साहब, thank you very much.
Sir,